So very good evening to one and all. So today we are going to see about this voltage control and how we are going to control this voltage. What are the causes of drop in the voltage in the transmission line and as well as the especially in the distribution system. Why? Because we are concentrating more on distributor system. What is the cause of voltage drop in the distribution system, and how we are going to rectify this voltage? That is how we are going to regulate this voltage at the distribution terminal. So that we are going to see in detail today. So as you see in the modern electric power system, the electrical energy is generated from generating station, and it is being delivered to the consumers to the network of transmission line and as well as distribution system. So for a satisfactory operation of motors, lamp, and other loads, it is desirable that consumers are supplied with substantial constant voltage. So consumers have to be supplied with constant voltage. Say if you take a single phase AC supply, you have to provide with 230 voltage, 230 volt, plus or minus 5%, 10% is being allowed. If you are having multimeter at your hand, so today, or otherwise any voltmeter in your hand, you can go to your nearby your switches, and you can note down what is the go to your nearby terminals, and you can note down what is the voltage coming to your home. They have to say, for example, if you are providing with a single phase AC supply, they have to supply 230 volt. So plus or minus 220 volt, like 210 volt is tolerable. If it is going down, like if it is going down like 200, 180, 160, then definitely there is a problem. There is some voltage drop in your particular place. So you need to complain to your electricity board, like you are receiving like very less voltage. Why? Because if you complain, as I said, some regulatory commission is there. Electricity board, that is generation corporation, Telangana State Generation Corporation, then distribution corporation, and your transmission corporation is there. But even though there is one regulatory commission is there, so that regulatory commission will monitor your voltage at that voltage and whether they are giving the reliable supply or not, and that too the voltage what they are providing is within the limit or not, because they electricity board assured you to give like 230 volt. They have to provide, like as I said, plus or minus 10%. So they can go beyond 230 volt up to 250 volt. It is okay. Then if they go down up to 200 volts, that is okay. So if they go really beyond below 180 voltage, then definitely your appliances will be misbehaving. Your sometimes you can also see, like in the morning time, in the peak hours at 8 o'clock or 7:30, 7 o'clock. So if you're on iron box, sometimes your iron box will not get heated up, and say you're just going to on your pump motors from pumping your water from underground tank to your overhead tank. Sometimes your motor will be giving some sound. It is also misbehaving, and sometimes your lamps, if you take at 6 o'clock, 6 p.m. in the evening, sometimes I'm telling about sometimes your lamp, your tube light will not get pick up. So it will take some more minutes, some 2 minutes, 3 minutes, 5 minutes to get pick up. So these are some of the voltage drop. And also if you are located near to some industries, the distribution transformer, what you connected to your home, the same distribution transformer will be connected to that particular industry. If you are located near to the industry, sometimes you'll be feeling this voltage drop, or like a flip in voltage. So what they do is, in the early days, like I'm saying about 10 years, 15 years back, exactly at 5:30 onwards, what they will do is they will simply on the tube lights and all the lights in the home, because after 6 o'clock, if you just on that tube light will not pick up, and it will misbehave. Like it will take some 10 minutes, 20 minutes, even half an hour also. Like, so exactly at 5:30 itself, they will switch on all the room lights in the home. So simply like that they can use. So after 6 o'clock, you'll get some flip in the voltage. So that also is there. And as I said, in the morning hours, sometimes your mixer grinder also will be running very slow. Instead of 1500 RPM, it will be running at 1200 RPM, like that. It will be running very slow. And sometimes in your TVs, if you are using like the older TVs, that is CRT monitors, so you can able to see some disturbance in your TV also. You can able to see some disturbance in frequent disturbance in your TV also, due to the voltage drop. Not LED TV, because LED TV, that is DC supply, like one okay, small like converter will be there. So that will be taken by your LED and LCD TV. But if you take like old CRT monitor will take some time. Initially, it will take some 30 seconds, 20 seconds to get started up. To on that CRT, like a CRT monitor, I think you're going to study that in your electronic subject, CRT concept. So in that CRT TV, you can clearly note down, due to the voltage drop, your monitor also will be misbehaving. You'll get frequent intervals of disturbance. You'll get some rains frequently throughout some half an hour, 1 hour, like that. So that also one sort of voltage variation, where you can see really practically this thing. But nowadays, due to the usage of modern, this is the modern power system, no? Modern power system. So somewhat this voltage drop is somewhat improved, but still in some remote places, if you are like you're far away from your distribution transformer, like 3 kilometers, 5 kilometers far away from your distribution transformer, you'll be feeling, if you note down your voltage in that particular your home, you'll be feeling that voltage drop. Like where I'm staying in that region, I have monitored that voltage. So sometimes my like induction stove will not pick up. In the peak hours, my induction stove will not pick up. Why? Because I have purchased one recent induction stove, like latest induction stove, with some voltage. It will be having some like voltage filtering circuit. Okay, so if it comes to this much voltage, like 200 voltage only, that coil will pick up, or otherwise my induction stove will not pick up. So like I felt some 2 years the same, some 1 year the same disturbance in peak hours. I can't able to on my induction stove, whereas in non-peak hours I can even use in after 10 o'clock, that is 10 p.m. I can easily use, and even in the morning peak hours from 7 o'clock to 9 o'clock, I can't use that induction stove. Why? Because that is the latest one. It will not allow that voltage, that filter circuit will be there. That will not allow that coil to okay on. So that is also. So what I did is I have purchased the old like without any features. I have purchased only simply on and off will be there. Simply on and off, and I can vary the temperature like that. The simple, with simple features, I have purchased another one induction stove. So that is working. So that induction stove will not have any filter circuits. So simply like that, it is working. So when I measure the voltage, when I measured with a like multimeter, so it is coming only 170 voltage, single phase AC supply, even three phase also. It is coming 170 plus 170, 175 plus one. So that is somewhat remote areas. So if you are located in remote areas, if you are staying near to the distribution transformer, very near to the distribution transformer, you will be getting sometimes you'll be getting more than 220, 225 like that, 225, 30, 230, sometimes 230 non-peak hours. If you just measure the same voltage in non-peak hours after 10 o'clock, 10 p.m. after 10 p.m. You will get exactly 230 and more than that also sometimes 232 like that also you can get. But there is some tolerance limit. So if you say like the government itself has fixed some tolerance limit, it should not exceed like plus or minus. This is plus or minus 6 percentage is being given in this book, but this is very old. Now even it is allowing like 10 percentage plus or minus 10. Even if you see the nameplate details of your iron box, there is some operating limits of your iron box. So if you see like it will, you only that if you see the Philips iron box, it will only allow 180 voltage, and also like after 230 volts it will go up to 250 volts. So there is some limit, 180 voltage to 250 voltage. This appliance, that is iron box, will work only within this range only. Below that range your iron box will not work. Even you can test if you are having multimeter, whenever the voltage range is 170, even it can heat up. It can heat up only slightly. Only the coil will pick up. Otherwise, will not pick up. Some like latest iron box, even it will not on also. Like old iron box, if you see like old one, like coil based iron box, that iron box will work even in 150 voltage also. It will work in 150 voltage also it will work. And if you touch that, if suppose that coil, sometimes the coil will not like insulate. So if you touch, like you will feel shock also. Like I'm speaking about old iron box, coil based iron box. So that is also that. So these are some of the practical things, like how what are the things that voltage has to be controlled. So if you see, the principal cause of voltage variation at a consumer's premises is the change in load of the supply system. As I said, if you are locating near to the industrial areas, so that industry will consume more power, more voltage. So you will be feeling very less voltage on. So previously, I used to stay near to like an industry. So that industry, so that industry will keep on working 24/7. That three shifts that industry is working. So sometimes in my home also, my iron box will not pick up, my light will not pick up at a peak time. So many like disturbance I'm just getting. So due to that, like I've changed my house to some other non-industrial areas. Now also okay, but even though I'm getting only 180 voltage, even if you test now also, you'll get 180 plus 180 like that. So you'll not get exactly 230. So whereas in our college, we are getting why? Because we are using some regulatory circuit. So exactly you'll be getting 230 volt like that. If you measure exactly 225 above up to 230, you can get. But not in your home, because we are not using any regulators. But after the regulators, like AC regulators, after the AC regulator, don't measure before the AC regulator. After the AC regulators, if you test that voltage, it will come like exact to 230 volt. So there are many boosters also there. TV boosters are there, like LED TV also using. Then your refrigerators. Then like that, that also you can measure. Even if you are having multi-beat, like only around 100 rupees, you can easily buy one multimeter. So with that, you can easily measure and you can see how and even if you are getting below that 180 volt, below that 170 like that, you can really make a complaint like in this area I'm getting this much voltage. Really, they have to rectify that thing, because if you see the main like role, main like aim of the your power generating company or distribution companies, they have to give the reliable supply, and as well as this voltage range also they have to give some limits are there, plus or minus 10% they have to give. So you can really make a complaint, definitely you will get a reply to that complaint. Okay. So if when the loads on the system increases, the voltage at consumers also falls to an increased voltage drop. That is due to alternators, synchronous impedance, transmission lines, then transformer impedance, feeders, and distributors. Then reverse would happen should the load on the system increase. So these voltage variations are undesirable and must be kept within the prescribed limits, plus or minus 10%. So this is achieved by installing a voltage regulating equipment in such a places in the power system. The purpose of this voltage like the voltage control equipment is to increasing the utility in fast developing power system, because everyone has to utilize the power that is being given to us. So like without very less voltage, our like many of the appliances will misbehave. Sometimes while using trimmer also, now modern trimmers, it will be coming with a control circuit. So previously, if you buy a trimmer before 10 years, so sometimes it will run fast, it will run slow. So that also very like dangerous to while trimming. So that also there. So many electronic equipments also will misbehave. So nowadays, many things like even your phone charger also having your regulatory circuit. So even 180 voltage also you are getting, it will be converting that into DC voltage perfectly. That 5 voltage or 12 voltage depends on your applications for your electronic equipment. Next, importance of voltage control. So what is the main importance of this voltage control? In the sense, when the load on the supply system changes, the voltage at consumer terminals also changes. So due to the ever increasing in the demand, ever increasing the load, the voltage at the consumer terminals also will changes. The variations of the voltage at consumer terminals are undesirable and must kept within the prescribed limits for the following reasons. In case of lighting load, the lamp characteristics are very sensitive to change of the voltage. Even you can see sometimes while reading book after 6 o'clock, while reading something newspaper like that, so your light intensity will be somewhat will be dim, somewhat it will be increasing. Even in incandescent old lamp, you can really see. So nowadays LED you can't able to identify that. So like this bulb is there, incandescent bulb. In that you can that yellow color bulb. So in that you can easily see, like it will be illuminating very high. Sometimes it will be illuminating very less. So that voltage variation you can simply see with that incandescent bulb. So that decreases by 6% of the rated value. Then illuminating power may decrease by 20%. So illuminating power may decrease by 20. If voltage range decreased by 6%, illuminating power may be decreasing by 20%. So in that particular room, there might be of like intensity will be very less. If you are using, say in olden days, you can identify this one, but now LED and this thing is normal. Even whatever the voltage changes is there, it is giving constant light, like illumination. On the other hand, if the supply voltage is above 6%, above the rated value, the life of the lamp may be reduced by 50% due to the rapid deterioration of the filament. So, if it is going like this, your life of the lamp, life of the even if you are buying an incandescent lamp, that life is of this many hours. So generally, the life of the lamp will be in hours, not by in days or like that. It will be in hours. So it will last up to 1,000 hours, 10,000 hours, like that. It will be indicating. So only it will burn up to like 5,000 hours, 2,000 hours. So it depends on your usage. If you are using 6 hours in a day, so it will last up to the range. So like that, it depends on the usage. Your lamp life will be changing. So the life of the lamp will be reduced to 50% due to this rapid deterioration. Okay. So in case of power load consisting of induction motors, the voltage variation may cause erratic operation. If the supply voltage is above the normal, the motor may operate with a saturated magnetic circuit with a consequent large magnetizing current, heating, and low power factor. Okay, so if the supplied voltage is above the normal value, so what it will happen is, so in non-peak hours, sometimes non-peak hours, so supply voltage will go up to 240 volts, 250 volts, like that. So by that time, if you are running the motor, so your motor will get heated up like anything. And also, if you are running with a low voltage, also your speed of the motor will be very less. Speed of the motor will be less. So by that time, your pumping power of your you are using for pumping the water, pumping power will decrease. Sometimes only the motor will rotate. It will not pump the water. Only the motor will rotate. Sound might be changing. I'm not saying about the underground, like dip motor. I'm saying about whatever the motor you're having above that tank, ground tank. So that motor, you can really see the sound. The sound will be changing. Then the heat, if you go near to that motor and touch that motor, your heating will be heavy sometimes. Sometimes only sound will be coming. That motor will not be pumping like that. Many issues are happening in and out. So too many wide variations of voltage also causing excessive heating in the distribution transformer. So if you go to your distribution transformer, so your distribution transformer, that is pole mounted transformers, that is situated near to your street, that is of 11 kV bar, 430 volt, 450 volts range. That transformer, sometimes it will be that transformer oil will be heated like anything. So in some festival hours, many loads, say for example, Diwali is coming, or some festival hours, festival days are coming nearby. So in that time, so you will on, I think you will on almost all the lights after 6 o'clock, all the lights garden lights, everything you will on. So like in that time, and also every loads, ACs, your refrigerator, everything will be on. In that time, your distribution transformer oil will be boiling, heating like anything. So it will come like some bubbles also will be coming out. So some leakages also will be happening in your nearby your distribution transformers. But even though why that is happening means in sometimes your distribution transformers, due to the excessive heat, your oil will be boiling like anything. But why it is happening? Because your electricity board has to check your distribution transformer frequently. Frequently in the sense 1 month once. like 1 month, 30 days once they have to test the viscosity of the oil. But I don't know how many of your distribution workers, that is linemen, like assistant engineers, whether they are coming near to your distribution transformer and they're testing your like viscosity of oil like that. I think they may test 6 months once or yearly once, because all are government owned. So they may come and test your distribution transformers. Once if some faults coming from the transformer, they will come and test your transformers. Some breathers problem or some oil is leakages is there, then they will come and test. But even that is a rule. If you go and study the rules of your distribution sector, in that they will be having some certain rules. They have to go for a frequent check. That is monthly, 30 days once. They have to check the viscosity of the oil. They have to check the that breathers, that chemicals found in the breathers. So everything they have to check the distribution transformer, so that your life of the transformers also, distribution transformers also will be increasing, and also damages also will be, we can avoid the damages. Sometimes what we'll do is we'll just go by walking and in the streets. Sometimes your distribution transformer will burst. Burst means that oil will be coming out and burst, and it will fall onto the people, and it will be damaging to the life of the people also. Some cattle goes near to the distribution transformers. Sometimes what they will do is they will tie the cattle in the distribution transformer itself. So if the some fault happening means that cattle also will go. So like that also in villages they are doing. Villages unknowingly what they will do is they will tie the cattle, goats, cows, buffaloes and all to the distribution transformer poles itself. So there also like severe damages, life will be losing to that particular cattle. Like that, many things are happening. So these are the some of the things happening in the so this much importance. Why to monitor the voltage control? The importance of voltage control is very, very important. Why? Because your equipment life will be going down. Even you are buying a new refrigerator, so that life, say for example, you are buying a LG refrigerator. They are claiming like that life as 10 years, but only due to this voltage drop, only your that particular refrigerator is coming for only 5 years. So 5 years lost for you. Okay, why? Because even that particular area will be having some less voltage rate and a frequent voltage drop in that particular area, so that your life of the equipment also will be decreasing. So ultimate loss is for hours only. Ultimate loss is for hours only. Sometimes due to this voltage drop and sudden rise also, many accidents also have happened. Sudden rise previously, and nowadays everything will be controlled by your relays and circuit breakers. So even any like if it is goes beyond 250 voltage, suddenly there is the signal will go to your like a circuit breaker. The circuit breaker will break that particular feeder supply. So that will be safeguarded. Previously, I'm talking about 10, 15 years back. So if you read the newspapers, so you'll have many news like one particular area, all the TVs will gone, will bust or due to this voltage, sudden rise in the voltage, and also some other equipments will gone. Like that, many news you're getting in free time. I will used to discuss that incidents also, some accidents, how it has happened. Like so, next coming to the location of the voltage control equipment. So location of in the modern power system, there are several elements between the generating station and the consumers. There are many equipments nowadays in the modern power system, not in the old traditional power system. This voltage control equipment is used at more than one point in the system for many reasons. Firstly, the power network is very sensitive. That is, there is considerable voltage drop in the transmission and distribution system. Secondly, various circuits of power system has dissimilar load characteristics. So, dissimilar load characteristics in the sense, so load might be decreasing, then suddenly increasing, decreasing like that. So, due to that, also this voltage control equipment is necessary, and also location. Also, correctly you have to locate between the substation to your consumers, and also near to the distribution transformer or after the distribution transformer, you need to install certain like voltage control equipments. In practice, voltage control equipment is used at generating stations, then transformer station, that is substations. Next, feeders. Feeders if drop exceeds the permissible limits. So these are the areas in which you need to install your voltage control equipment. So methods, there are many methods to control this voltage, to control the voltage. There are several methods. In each method, system voltage is changed in accordance to the load to obtain a fairly constant voltage at the consumer end. Okay, so we all have to look on to the consumer end. What we are consuming, we are enjoying our power at the last end, So they are all more concerned about our thing only. That is consumer end only. So if fair constant voltage they are supplying to the consumer end, ultimately the life of whatever the appliances that we are having in our home, that life of appliances will be increasing. So defaultly, ultimate advantages is of ours only. What are the methods? The following methods of voltage control in AC power system are by using excitation control, by using tap changing transformers, auto transformer tap changing transformers, boosted transformers, then induction regulators, and by synchronous conduction condensers. So now we can see this excitation control. So excitation control, this is a very old method. That is the trill regulator and the Brovary regulator. This is full of mechanical arrangement. So nowadays we are not going for this arrangement to control the voltage. We directly go to this. Tap changing transformer, tap changing transformer method. So this excitation control is satisfactory only for relatively short lines. So shorter lines, we are going for this tap changing transformers. However, it is not suitable for long lines. For long transmission line, this tap changing transformers is not suitable as the voltage at the alternator terminus will have to be varied too much in order that voltage at the far end of the line may be constant. Under certain situation, the problem of voltage control can be solved by employing other methods. One important method is to use this tap changing transformers. Okay, so if you see this is the off-load tap changing transformers. I think transformers you already studied. So what is the usage of the transformer? The transformer is a device which converts one form of the voltage into the another form of the voltage without changing the frequency. So frequency is maintained constant. Only the voltage can be stepped up or stepped down. Sometimes in a generating station, it is stepped up. Why? Because it has to travel for very long distance, 300 kilometers, 400 kilometers. It has to travel and it has to reach your load centers and nearby distribution systems. So in that scenario, what we are doing is we are going for step-up transformer. Sometimes we are going for step-down transformer. Step-down transformer you'll be fine near to your homes. That is your pole-mounted transformer. That is step-down transformer. That is 11 kV bar, 415 volts, step down transformer. So now we are going for using this off-load tap changing transformer. So this is the arrangement you're showing. So transformer having two sides, that is primary side and as well as secondary side. So in the secondary side, you will be having this more tappings, more turns, more tappings. As the position of the tap is varied, this is the tap. This is the offload tap changing transformers. Nowadays, not they are using. But even though you have to know the working, how it is being worked, like that you have to know. So there will be some moving arm. So someone has to go near to the transformer manually. They have to change the tappings. There will be some tapping range. So if the say for example, if the voltage you want to increase, so you have to turn the taps. You have to turn the taps so that the secondary side, it will be step up and you will get more voltage. So sometimes the voltage is coming 180 voltage. So somebody, your lineman has to go near to that particular tap changing transformers. What he will do is he will change the tap. He will change the tap. That tap also will be changing so that the voltage will be varying to 230 volt or more than that. So whatever the range. So in substation also, you will be finding this tap changing transformer. So in that also they will be changing this taps. But you should be very, very careful while doing this operation, while doing the tap changing transformers. Sometimes even though the insulators used in the operating point, sometimes due to the insulation failures, so if you see in the substation, it will be of very, very more power, it will be of 33 bar, 11 kilovolt. 11 kilovolt supply, you're directly going and operating. So one incident happened. I just want to tell. So one operating person, those who are operating that particular substation, what he did is he just operated this offload tap changing transformer without wearing the gloves. Actually, if you want to go near to the transformer tap, transformer yard, you have to wear a gloves. There will be some exclusive gloves will be there. It will be insulating that power. So you have to go, you have to wear the gloves and you have to go near to that particular tap changing transformer and you have to turn that tappings. What he did is on the day, one fine day, he didn't wear that glove. Directly he was operating because those who are working workers, they will be having some 10th standard. They studied only 10th standard. By experience, they know. Simply like that, they will be giving the command to operate that tap changing transformer. Simply like that, they will go and they will change. So without wearing the glove, he operated, and his whole hand got removed. Why? Because so that much power, due to the even though that is insulator, sometimes due to the failure of insulation, so directly it will be coming. So here you'll be finding one. So within this two terminals, you'll be finding one pipe type thing will be there. So you need to go to that thing and you have to turn that pipe. Then only this arm will move. Either you have to move like 4 to 5 or 4 to 3 like. So directly that insulator failure on that day, on one fine day. So that he lost his whole hand. Okay, his whole hand directly his hand got connected. That is communicated directly. His whole hand got connected, and his whole hand got burnt. And they went to hospital. They just removed the whole hand itself. Like that, I'm telling about only one incident. Like that, many incident was happened. So those were working and operating in the substation, they need to be very, very careful while operating this this transformer, that's tap changing rods. Even your lineman also sometimes will be simply off and on without wearing gloves. So like many times will not be a good time for us. Sometimes it will be good, and sometimes due to the installation failure, you may able to lost your life or your hand. Like, so you have to very, very careful while operating this kind of like transformers. Yeah. Next, coming to the transformer, hence the output voltage of the secondary also will be changed. So if you're varying, if you want to increase or decrease, it will be changed. Uh, while referring to this figure, while movable arm makes the contact with the stud one, this movable arm contact with the stud one. The secondary voltage is minimum. When when it is the stud 5, it is maximum. When it moved like this, it will be maximum. When it moves to 1, it will be minimum. So due to the range, you can operate whichever the range you want. You can operate. You can lower down or you can make it to higher range. Due to the period of light load, the voltage across the primary is not much below the alternator voltage, and the movable arm is placed on the stud 1. Okay, so the voltage across the primary is not much below the alternator. So light loads, you have to move this arm to 1. So like higher loads, you have to move this arm to 5. But when the load increases, the voltage across the primary primary drops, but the secondary voltage can be kept at the previous value by placing the movable arm on the like higher stud. Whenever a tapping is to be changed in this type of transformer, the load is kept off, and hence the name. It is called off-load transformer. So here you have to know that whenever the tapping is to be changed in this type of transformer, load is kept up. So here secondary side your load will be connected. So what you have to do is here one feeder will be there. Okay, so you have to open this feeder. Then only you have to come here and you have to operate this like tappings. Whether you have to change to like maximum or minimum. So like that, this tappings you have to change. So by that time, your load should be kept off. This is the main disadvantage of this off-load tap changing transformer. Why? Because you, while operating this type of tap changing transformer, you will be getting some flip in the voltage. You will be feeling some 1 minute you won't get power. After that only you will get power. So while using offload transformer, offload tap changing transformer, it will definitely take 1 minute or more than that. 1 or 2 minutes you will get off. Like power will be shut down at that particular place. Even sometimes your lineman will be coming to your home now for sometimes what it will happen is in our home itself some lines that is that wires that is connected to that particular pole uh, uh, will be not connected to that due to some heavy winds and all. It will be not connected. By the time what your lineman will do is he will go to your nearby distribution transformer. He will off that particular distribution transformer, that is feeder, or sometimes. Then again he will come to that particular pole. Again he will climb, and again he will connect that particular wire with that line. That is 415 voltage line or 230 volt line. He will connect. That is three phase 230 volt. Three lines will be there now. He will connect into that. Single phase means he will connect into one line like. So he will often come. Then only this is being possible. So this is the main disadvantage. The principal disadvantage of this circuit is it cannot be used for. Suppose for a moment that tapping is changing from position 1 to position 2 when the transformer is supplying load. If the contact with stud 1 is broken before the contact with the stud 2 is made, then there is a break in circuit and arcing results. So sometimes arcing also will come while switching on or switching off. I will show you a video in some other class. While switching on and switching off, one severe arc will come. One severe arc will come. So that arc also will come, and also you will feel it. You will feel some 1 minute, 5 seconds flip or 2 seconds flip in the wood. Sometimes in your home also you can feel. Sometimes you'll be watching your TV, like constantly you'll be watching your TV. So sudden flip, you do the sudden flip. So that TV will be off for just some 5 seconds. Again, what you have to do is you have to switch on your like television with your remote. Again, you have to watch your TV. So like that, you have to do in that particular time. And also there is some flip while doing. So you're using some mixed rate. So in that time, what it will happen is suddenly there will be a drop. So suddenly due to this tap changing, there will be some often the power of some like 30 seconds or 1 minute like that. So all your appliances will be off for sometimes. Again, it will on like that. Also, it will. So what is main reason? On the other hand, if the contact with stud 2 is made before the contact with the stud 1 is broken, sometimes this contact also will be is broken. Then the coils connected between these two tappings or short circuited and carry damage heavy currents. Okay, so due to this short circuit, between two studs, also will carry heavy currents. So this for this reason, the above circuit arrangement cannot be used for the tap changing on the load. So on load you can't use. So you have to off that particular. You have to cut to that particular load. Okay, with that feeder for some times. Then only you have to come for your. You have to on your loads. This is of your offload transformer.